Hello everyone. Today we are going to discuss Woodward-Fieser rule for calculating lambda max in conjugated dienes in UV visible spectra. So here you can see the 5 examples and we will discuss one by one. But before discussing it, we should know what is the Woodward-Fieser rule. Actually, Woodward and Fieser gave some values for the different diene systems and increments values for different functional groups and different alkyl and ring residues. So here you can see these are the base values or also called the parent values. Base values, the system diene system may be acyclic, there is no cycle, or it may be cyclic. If it is cyclic, so it may be heteroannular diene system or homoannular diene system. We will discuss these terms later. So here suppose that diene system is acyclic or heteroannular diene, then the value, parent value or base value is 214 nanometer. If the system is homoannular diene, then we will take this value, that is the 253 nanometer. And after considering these base values, the other groups we will consider as the for the increments. And suppose that there are alkyl groups like R or the part of the ring residues, then it will contribute 5 nanometer. And if there is exocyclic double bond, we will discuss later what is the exocyclic or endocyclic double bond. So exocyclic double bond, that will contribute 5 nanometer. And double bond, suppose that there is one double bond exocyclic to two rings. The same double bond is exocyclic to two rings. So that will contribute the double value of the single exocyclic double bond, means plus 10 nanometer. And if any double bond extending conjugation, means there may be the diene system and there is extra third double bond, so that will contribute to the 30 nanometer. And there may be some functional groups. If functional group is acetate group, it will not contribute any value. And if the any halogen is there like chlorine or bromine, that will contribute 5 nanometer. And the ether group, alkoxy group, will contribute plus 6 nanometer. And the thioether will contribute the 30 nanometer. And amine derivative like amine, NH2, NHR, NR2, so that will contribute 60 nanometer. And if suppose that we want to calculate the lambda max value in different solvents, suppose that these values are given in ethanol and we want to calculate in hexane or cyclohexane, so in that case there will be no solvent shift because that will be negligible or minimal, so there will be no solvent effect in the diene systems. So now we will take these terms acyclic dienes. Acyclic dienes means there is no cycle. Suppose that this is the diene, two double bonds in conjugation. This is called diene, and this is acyclic diene. Now if it is the diene system, the two double bonds in conjugation are in the cycle, then this will be called cyclic, and annular term is used for the cyclic ring. So here if both the double bonds of the diene are the part of the same ring of the one ring, so that is called the homoannular dienes. So there is only one ring and both the double bonds are the same ring, so that is homoannular diene. And here there are two rings, suppose that A and B, so both the double bonds are in the one ring, so that is homoannular diene. And here also suppose that there are two rings and here this is both the double bonds are part of the second ring, although this double bond is the part of both the rings, but the diene system is the part of the second ring, that is B. So this is also homoannular. And suppose that this is like this, here there are two double bonds which are homoannular diene because these are the part of the one ring. Although these carbon are the part of the second ring, but the diene system is the part of one ring. So these are the homoannular diene. We can identify them. Now the another is heteroannular diene. Heteroannular means when the double bonds are in different rings. So suppose that there are two rings A and B, and here one double bond is a part of one ring and another double bond is a part of the second ring. Although this carbon is also part of the second ring, but the double bond, both the carbon are not part of the second ring B. So both the double bonds are in different rings. So this is heteroannular diene system. And here also you can see the both the double bonds are or the part of the different rings, the A and B. So this is also the heteroannular diene. So we have to identify them. Next thing is the endocyclic double bond or the exocyclic double bond. Here you can see this is the cycle, and in the cycle this double bond is endocyclic. This is endocyclic. Endocyclic means the both the doubly bonded carbon are the part of the ring. दोनों ही ring की both are in the ring. So this is the endocyclic. And here you can see this is the exocyclic. This is outside of the ring. So this is exocyclic. So either you can say that this is the out of the ring or outside of the ring. So this is exocyclic, or you can say this only one carbon is the part of the ring, another carbon is not the part of that ring. So this is exocyclic. Or you can see this double bond is opening in that ring. So this is out of the ring, outside of the ring, so exocyclic. So here you can see this is the endocyclic. Suppose that this is A, this is ring B. So endocyclic for the A ring. This is also endocyclic for the A, but this is exocyclic for the B because this is the outside of the ring B. So this is exocyclic. Here both the double bonds are endocyclic for A because both the doubly bonded carbon of both the double bonds are part of the ring A. But for ring B, if you see, suppose that this is the ring B, so you can see this double bonds are outside of the ring. So these are exocyclic double bonds. So there are two exocyclic double bonds. Now here you can see there are two double bonds. This is endocyclic, right? Both the carbon are the part of the ring, but here this is endocyclic for the ring A, but exocyclic to ring B because this is outside of the ring B. So there is one exocyclic double bond. There are two double bonds. So this double bond is exocyclic to B ring, and this double bond is exocyclic to A ring. So there are two exocyclic double bonds. Here you can see this is the endocyclic double bond and this is exocyclic. Suppose that we mark this A, B and C, all the three rings, and this double bond is exocyclic to B ring, and this double bond is exocyclic to A and B. So this double bond, the same double bond is exocyclic to two rings, so it will contribute plus 10 nanometer, and there is this exocyclic double bond will contribute only plus 5 nanometer. Now we will take this the examples one by one. Here this is the example of acyclic system. So we will take the base value first. Base value. The system is acyclic diene. So base value for the acyclic diene will be 214 nanometer. Now we will mark this conjugated system, diene system, and here you can see this is the one double bond, second double bond, the conjugated double bond. So this is diene, acyclic, there is no cycle, and this is cutting. When we are marking, this is cutting these alkyl groups at 4 places. So there are 4 alkyl groups. 4 alkyl groups means 1 is contributing 5, so 4 will contribute total 20 nanometer. Because there is no cycle, so there is no exocyclic double bond and there is no extra double bond, so no extended conjugation. So only these things are there. So calculated lambda max will be like this, will be 4 3 2 234 234 nanometer. Now this is the second example. Here you can see the both the double bonds are in the same ring, so this is the homoannular diene. So first we will mark it. You can see this marking, and here base value for the homoannular diene. Base value for homoannular diene will be this is 253. This is not this is 253. Yes, 253 nanometer. Now increments we will add. Increments will be like there are one alkyl group, so one alkyl group, this will contribute plus 5 nanometer. And now how many ring residues you can mark? This is one, this is another cut second, and this is third one. So total 3 ring residues, ring part of the ring, 3 ring residues. So there will be 3 into 5, total 15 nanometer. Now we will see whether there is any other extra double bond. No. Or there is any exocyclic double bond. Yes, this double bond is exocyclic double bond to the second ring. So there is only one exocyclic double bond that will contribute plus 5 nanometer. There is nothing else, so we can sum up them. So lambda max calculated will be 5 10 15 18 6 7 and 278 nanometer. Now the third example is this. Here you can see both the double bonds are in the different rings. So here this is the example of heteroannular diene. So here base value or parent value for the heteroannular diene will be 214 nanometer. And now we will mark this system, diene system here. So this is the conjugated system starting from this carbon ending at this carbon. So this is the conjugated system. So in this conjugated system you can see one cut is here, second and third and fourth. Total 4 cuts are there. So it means there are 4 ring residue. There are 4 ring residues. So 4 into 5, total 20 nanometer it will contribute. Now we can see that is there any exocyclic double bond? Yes, this double bond is exocyclic to B ring, and this double bond is exocyclic to A ring, the first ring. So there are 2 exocyclic double bonds. 2 exocyclic double bonds means they will contribute 5 into 2 means plus 10 nanometer. Is there anything else? There is no extra double bond, and one chlorine atom is there. But that is not on the conjugated system. If that is not the part of the conjugated system, it means that is not attached with that carbon which is the part of the conjugated system. We will not consider it. It will not contribute anything. But if suppose that if it would be here, would have been here, so that definitely we will add. We would have added plus 5. But this is not on the conjugated system, so this will not contribute anything. Okay, so now we can sum up them, and the calculated lambda max will be, can see this 4 2 3 4 and 244 nanometer. This will be the lambda max calculated. Now the next example here is fourth one. You can see here there are three double bonds. So if we consider these two in the ring A, so this is homoannular diene, and if we consider the double bond of this one middle one and the right one, so these two are the heteroannular dienes. So when in the molecule both the diene systems are available, means homoannular as well as heteroannular, then we will consider that particular system, conjugated system, which gives more values or the higher value. So we know that homoannular diene gives the more base value, higher base value. So here base value we will consider for the homoannular diene, means system we will consider homoannular diene. So value is 253 nanometer. Now increments we will consider here. First of all, we will mark the conjugated system. You can see here it will start here in this, not this side, this side. Yes, this is the conjugated system. So here you can see conjugated system, there is no alkyl group. This is the functional group, alkoxy group, ether group. But other ring residues you can mark 1, this is 1, this is second, this is third, this is fourth, and this is fifth. So there are total 5 ring residues, means 5 into 5, total it will contribute 25 nanometer. Now we will see whether there is any exocyclic double bond. You can see this is not exocyclic. This is not exocyclic, but yes, this is exocyclic to the ring B. So there is one exocyclic double bond. Exocyclic double bond to ring B. So it will contribute 5 nanometer. And there is this double bond, this is exocyclic for ring A and C. So there is one double bond exocyclic to two rings A and C. So it will contribute the double value, that is the plus 10. Now there is one extra double bond. There are total, this is the conjugated system, homoannular we have considered, we have taken the base value. Now this is third double bond. So this will extend the conjugation. So one double bond extending conjugation. So that will contribute 30 nanometer. Now, is there any functional group? Yes, there is one functional group, that is alkoxy group, and one OR group will contribute plus 6 nanometer, and there is nothing else. Then we will sum up them, and the lambda max calculated will be, here you can sum up 5, 10, then 16, 19, 9, and 5, 6, 8, 9, 12, 3. This is 329 nanometer. Now the fifth one example, here you can see here there is this is the homoannular diene system, and this is the heteroannular diene system here, and this is middle one. In the middle also there is the homoannular diene system. But if you see this, this is the conjugated system, there is only this one up to this, right? and here this is another system, this is here coming to the this carbon. So there is, this is the example of cross conjugation. This is the example of cross conjugation. So there is the branching. This is not in the continuity, right? So here suppose that we are considering this one, so this should go from this side, but there is conjugation break. But if we go from this side, so there will be here this time there is the branching of the in the conjugation. So this is called the cross conjugation. So whenever there is a cross conjugation, we will consider the highly conjugated system and highly branched system. So you can see here there is, if we consider this double bond, then only two double bonds will be in the in the system. But if we consider these bonds, so the three double bonds will be there. So the system, conjugated system, will be this one. So this is very important to identify that which system is there and whether their cross conjugation is there or not. So there is cross conjugation, so we will consider this highly conjugated system. There is one homoannular diene, one extra double bond, and highly branched. So here base value will be for the homoannular diene. Both, if both the systems are available, have homo and hetero, then we will consider that one which gives the higher value, and that is the homoannular diene. So 215 nanometer. Now we have marked the conjugated system. Here in the conjugated system, you can see there are ring residues, the one ring residue, second ring residue, and this is third one, and this is fourth one. Total 4 ring residues. So contribution will be 4 into 5, that will be 20 nanometer. Now we will see whether there is any exocyclic double bond. This double bond is not exocyclic to any ring. This is also not exocyclic, but this is exocyclic to the B ring, A, B, C, suppose that middle ring. So there is one exocyclic double bond. So this will contribute plus 5 nanometer. Now we will see whether there is any extra double bond. Yes, with the other than conjugated diene system, there is one extra double bond. So there is one double bond extending conjugation. So that will be contributing 30 nanometer. And if you see this functional group, there is a functional group acetate, although this contributes 0, but still this is not the part of the conjugated system. This conjugated system start from here and end at this carbon. This is going this way, but this is not going this way because this double bond is not the part of the conjugated system. So this acetate group is also not the part of the system. So this will not contribute anything, although acetate group contributes 0. So but this is not the part of the system. If any group also suppose that other groups would have been there, so that also would have not been contributed anything. So this is all, and now we can sum up them. So lambda max calculated will be, you can count here, this is not 215, this is actually 253. This yes, this is 253 because homoannular diene contribute 253 nanometer, right? Okay, yeah. So 5-3, yeah, and exocyclic double bond is there, okay, and there are, okay, yes, this value will be 5, 3, 8, and this is 7, 10, 3, 308 nanometer. Is it right? Just let me just check it again. 1, 2, 3, 4, 5. Okay. Yes. Just see, in this molecule there are total how many ring residues? One. This is second here, and this is third, this is fourth, and this is fifth one. Total 5 ring residues. So there are total 5 ring residues. There are not 4. There are 5 ring residues, means 5. This will contribute 25 here. 25 means 5 extra. So total here will be, this will not be the correct one. This will be 330 nanometer. Okay. Yeah. So we should see clearly the molecule, and we should mark the conjugated system clearly, and then we should count the ring residues. So there are total 5 ring residues: 1, 2, 3, 4, and 5. Total there are 5 cuts. So 5 ring residues. So total 25 values. So this will be the lambda max values. Thank you.